And like I said, the quizzes on 91 and 92 were really good. If you have some corrections you want to make, what is today, Wednesday? Let's try to have about middle of next week if you want to make them, but it won't take you very long. You guys did a great job on that. Gabe is gone. Okay, kids, law of science today. It's going to be kind of straightforward with this. Sounds kind of difficult, doesn't it? A little bit. Okay, guys, law of science is going to be a focus that we talk about today, and here's kind of what I want you to revert back to. You guys remember when we started chapter 8? We had said that anytime you deal with a triangle, I'm just going to draw a triangle up here to kind of reference off of again. Okay, you might want to do the same. Anytime we're dealing with triangles, I don't care if it's a right triangle, an acute triangle, or an obtuse triangle. When I say acute, I'm talking about all angles less than 90. What do I mean by right triangle? A 90-degree angle. And if I say obtuse, one of the angles is more than what?
90.
Okay. When we talk about this right here, if I call this angle A, B, C, do you guys remember that when we talked about opposite sides right here, if angle A was down here on the left, where was side A at? Opposite of it, right? Okay. So what would this side on the bottom be? B. And what would you want to put over here? Okay, so you always use capital letters to denote the vertices of a triangle. And then the lowercase letters are going to denote the sides. Okay, but just kind of recall that when we're talking about triangles right now, you're going to have an angle A opposite of a side A right here. Same with B's pair and C's pair. Okay, so the question we're trying to answer is what the heck is law of science and how does it help us? Okay, so guys, here's what I'm going to tell you today. We're going to use law of sines a little bit to help us, first of all, find areas of triangles. And then we're going to use law of sines to do what? Okay. Guys, you can use law of sines if you have an angle and its side along with something else. So kind of let me tell you what I'm talking about. Okay. Let's suppose I gave you, we have angle B that we knew. We knew side B. So is that the angle on the side it belongs to right there? Angle B and side B right here? And then when I say something else, it means you need one more piece of information, whether that's another angle or another side. Okay, so an example might be you've got angle B, side B, and maybe side A. You can solve a triangle that way, meaning you can find all three angles and you can find all three sides. So law of sines works if you have an angle and its side along with what?
Something else.
Something else, okay? Now here, guys, is the definition today. Law of sines is our only vocabulary that we're focused on. And it says right here, for any triangle ABC and side lengths little a, little b, and little c, the ratio of the sine of A to A is equal to sine of B over what? Which is equal to the sine of C over what? C. Okay? Or we can flip that around. We can put the sides up top and the sine of the angles on the bottom. Okay? Now I prefer this method up top. I just have always worked this way. I think it's easier. All right? And I think that you know, you'll figure out what you want to use, but I like that top method best. Okay? So kids, we're going to talk about some things today. Things that we need to kind of look at here a little bit and understand. When we solve triangles, we're not always going to be given an answer that's in our calculator. We're going to have to look for others that don't show up in the calculator. And let me show you why here quickly. Guys, example 1 says find the what? For obtuse angles. Now I want to show you something real quickly. You don't need to write this down, but just recall this. Kids, where does 30 degrees lie? Which quadrant?
1.
So if I had this up here as 30 degrees, what law are we talking about again, kids? Okay, punch in sine of 30 degrees in your calculator. Tell me what you've got for a value. Punch in sine of 30 degrees and see what you get. 1/2, is that right?
Mm-hmm.
Okay. So there's going to be times when we're looking for angles right here. We might be looking for an inverse sine of 1/2 right here to kick us back 30 degrees. But I want you to think about something here at least before we get going into this too much. The sine value is like the y value, how far above this would be, or it would be opposite leg over hypotenuse in a unit circle. This would be 1/2 right here. Okay. Let me ask you a question though. What if I did 150 degrees this way? Punch in sine of 150 in your calculator. That's saying that this distance is 1/2, okay? What's a reference angle for 150 degrees, kids? 30 degrees, right? Okay, so we're gonna start talking about this idea that your calculator might kick 30 degrees out, but we're also gonna have to check out what other value here today. 150. Okay, it's just out of curiosity, what do 150 and 30 add up to? So if we're working ahead today, I find a 20-degree angle. We might also have to check out what's 20 from 180? 160. Okay, we'll talk about that more as we get further into it. Okay, but do you understand why these two are the same value right here? Sine of 30 and a sine of 150. Yeah. Yes. Okay. All right. Let's go back to where we were. So we're going to be working with some obtuse angles now. We're not dealing with just specifically right triangles anymore, kids. So let's just make sure we all agree on our calculators first. Make sure we're all in the right mode, okay? This down here says evaluate each trig function using a calculator. Round your answer to how many decimal places, kids?
4.
4 decimal places. So when you punch in tangent of 92 degrees, what's a kick out at you?
Negative 28.6363.
6363. Okay. How about sine 175? What's that throw at you?
0.0872.
Okay, everybody in agreement so far? And then how about cosine of 149?
Negative 0.8572.
Negative 0.8572. Okay. So, as long as we're matched up here and your calculator kicks out those values, I know that we're at least in the right mode there. All right? Okay, well, let's get into this. What are some things that we need to discover? One of them was finding areas of all triangles now. Guys, first of all, what's a formula for the area of any triangle that you know off the top of your head?
Base times height divided by 2.
Base times height divided by 2. But do we always have a base and do we always have a height? Not always, okay? So here's this situation right here. At the top of page 2, there's this core concept that says finding an area of a triangle, okay? Now they've labeled their triangle here ABC, so the sides that are opposite are put in the correct spots. Core concept today says the area of any triangle is given by 1/2 the product of the length of how many sides, kids? 2 sides and what?
The sine.
Of there, and the word I want you to circle right here is what? Included angle. So it says for triangle ABC shown over here on the left, there are 3 ways to calculate this area. I'm going to talk about the first one right here. Okay? This here says the area is equal to 1/2 B times what?
C.
Times the sine of what?
A.
Let's just find little b and little c. Here they are. Okay, kids, if you took side B and you took side C and you said, where do they cross? What angle would they meet at? Okay, well I talk about this right here. The area of any triangle can be found by taking one side times another side as long as I know the angle that those 2 sides make up. So in other words, do you agree that B and C make up angle A right here?
Mm-hmm.
Could I have used B and C and say angle C over here? Does this side and this side make angle C? Okay, and then maybe a way to remember it is this. Okay, if I have sides B and C, what angle do we need to use? If I have A and C, what's missing? Need the sine of B. If I have side A and B, what angle do we need to use? Okay, so let's see if we can't figure this out. The area of any triangle can be found by the product of 2 sides cut in half times the sine of its included angle here. Okay? Well, this one's not so bad. Do we have 2 sides? What 2 side lengths do you have? 12 and 15. What's the angle that's formed by those 2 sides, lengths 12 and 15? Okay, do we have the two sides and the included angle? Okay, so my area of this would equal 1/2 of, okay, what two side lengths, kids? What and what?
12 and 15.
12 times 15 times the sine of how many degrees, kids?
110.
So you're just going to punch on your calculator just like that. 0.5 times 12 times 15, sine 110. One thing I want you to get in the habit of is this. You know when you kick out sine or cosine your calculators, it puts that first parenthesis right away, right? Get in the habit of putting the trailing parenthesis in after your function. So when you type in sine in your calculator, it puts that in right there for you automatically, doesn't it? Make sure you get the trailing one in there as well. All right. So if you go 0.5 times 12 times 15 times sine of 110, what kind of area do you end up with here?
84.572.
Okay, and we can go nearest 10, so about 84.6.
Yeah.
Okay. I'm going to give you a triangle. I want you to tell me which measures to use to find the area. Okay. You guys good with that right there? Okay, I don't care about you computing this. Here it is, though. I don't know. Maybe this is 22. This is 12, and this is how about 31? And I tell you that this is 22 degrees right here. If I want the area of that triangle, what values would you have to use? 31 and 12 and sine of. So you would go half 31 and 12 and sine of. Okay, why can't I use this 22 over here?
It's not that angle.
That side doesn't form any part of the angle, so is the side 22 included on the angle, you know? Okay, are you good with that? All right, friends, then let's back up here. And then let's establish what we really need to establish today, okay? Finding areas, simple formulas up here. Do I need to do more examples, or can you apply those okay?
We're good.
Okay. Friends, here we go. Let's get into this right here. All right. I love example 3, what they talk about. They say, solve a triangle for, what's this say up here? Okay, angle, angle, side, or, let me just show you what they're even talking about here, okay? I'm going to draw two angles, or two triangles up here. They don't have to be perfect. Okay? Here's kind of what they're saying. They're kind of saying that you know an angle followed by another what? Then followed by a what? So this is kind of like saying, you know this angle here, you know this angle here, and then you would know that side right there, following in terms of angle, angle, side. If you ever have two known angles and a side after the two known angles, not in between the two angles, there will always, always, always be, what's it look like here, kids?
One solution.
Okay. The other case is an angle, side angle. Let's say you know this angle, then a side, then another angle like that. If that ever happens, you'll have one triangle. Okay? Now, guys, think about this. In both cases, how many angles are they giving you?
2.
Guys, if I give you two angles of a triangle, can you easily find the third?
Yeah.
So really, if you know two angles, then you really know
All of them.
three angles. So I'm going to make a note up here, guys. The deal is this. They're giving you two angles. So if you have two angles, you really know all three. Okay? So let's talk about how we solve this triangle. Solving a triangle means find me all the lengths of the sides and find me all angles. Okay? In this first example, how many angles do they give you?
1, 2,
2.
Two of them.
all
Okay?
angles, yeah.
So I like to set my work up like this. I like to set it up as angles first, and then sides over here. Okay? All right, I use capital A, capital B, capital C for angles. I'm going to use little a, little b, and little c for sides. Right? So what's known so far, kids? What absolutely 100% do we know?
Big A.
Big A is 38 degrees, right? He's such a cold-hearted son of a gun. How about C?
115.
Smoking hot, right? What else do we know?
Little A.
Okay. Now, those aren't changing. Those values will not change at all. Those are given to you, and those are going to be constants. Okay. Thing that we need to figure out here, kids, is angle B, side B, and side C. Well, like I said up here, guys, if you know two angles, you really know what?
All of them.
Okay, so how are you going to find angle B here, friends?
Isn't it 180 minus 115 minus 38?
Yep, so again, just a quick reminder, I'm sure you all remember this, but the sum of all the angles in any triangle, how many degrees? So if I do 38 plus 115, oh, help me out, kids, is that 153? What's 153 from 180 then? So angle B must be 27 degrees, right? Okay. Now we got to find side B in this, friends. And this is where the law of sines comes into play. So here's how this works. So up there, was there a pair given to us? In other words, an angle and its corresponding side that we know. A, B, or C's? We know the A's. Okay, so I can set this up like so. I can set this up as follows. I can say, you know what? By law of sines, the sine of 38 is to what length, kids?
25.
Okay. We're going to find B first. Is that okay? As the sine of how many degrees here, kids? Is to what?
X.
In this case, we'll just call it little b. Is that okay with you guys? Okay, so you get b alone. Isn't this just a proportion, friends?
Yeah.
So you're in your calculator. You're going to go sine 27. Make sure you put parentheses around the 27 like this. You're going to go sine of 27 times what, kids? Divided by what? Okay, go ahead and do that for me. When you do sine of 27 times 25 divided by sine of 38, again, make sure you're putting both parentheses around the degree measures. I'd say nearest tenth would be good. 18.4. Any confirmation out there, kids?
Yeah.
Okay. So 18.4 units. Okay. Well, I'm going to get rid of this down here at the bottom. Guys, what do you think we're going to do to find side C?
The same thing.
Same thing. I'm going to set up sine of 38 over what again, kids?
25.
Over 25. That's going to equal the sine of what?
115.
Over.
C.
What do you guys get?
36.8.
36 point. You said 8? I bumped this. I got to recalibrate. Give me a second. All right, I want to show you something real quickly now. The nice thing about law of sines is this.
I didn't get that.
Oh, you didn't get 36.8?
No.
I did.
Okay, did you go sine of 38 over 25, or sine of 115 times 25 divided sine of 38?
Try again. Now I got it.
We're good now? Okay. Now the good thing about this is what's nice is this. We actually found side B before we found side C, didn't we? And maybe I just forgot about A. I could have done this also, kids. I could have gone sine 27 over, what did we get for B when we found that in the second step?
18.4.
That would have equaled, again, the sine of 115 over C. Now you can trust me on this, or you can punch it in, but guess what you're going to get out? 36.8. That would have worked as well. Okay. So I want you guys to try this next one on your own. All right, make sure you're good with this. So we've got side A, or I'm sorry, angle A, angle B, angle C. Okay, what angles do we know, kids? And what else? And then what side do we know?
A.
What is A?
24.
So kids, right here, I can't do this problem because there's no angle that matches a side. We don't have a side and an angle that's a pair, do we? Better give up on this one, right?
Yep. Only way.
Okay, now think about what I said earlier though. But if we have two angles, you really have what? Three. So if I find angle A, then do we have a pair to start working with? Okay, we could work with angle A and what? Side A. So you guys figure out what angle A is and then get into your law of sines, figure out little b and little c here. What did you guys get for angle A, by the way?
81.
81 degrees.
What?
Anybody got side B yet?
Yep.
Yeah.
What was side B?
13.9.
13.9? Are we in agreement, kids?
Yeah.
Do I need to go over it?
No.
Anybody got side C yet?
Not yet.
31.8?
21.
21.8. Now kids, one way to check on stuff like this is as follows. If you would look at your angles right here, in terms of order from least to greatest, what's your smallest angle up here?
35.
Which would be angle B. Then what angle?
C.
Up to the largest of?
A.
Okay, so the order on this from least to greatest goes B, C, A, alright? Right here, if you have a certain order on angles, it's got to go the same order as sides. So what's the shortest side here?
B.
B to what then?
C.
To what?
7.
If your orders on sides and angles match, what do you think is going to be true of your work then? It's probably going to be right. Okay. All right, are we good on these values? Any questions about how I got 81 degrees here first? Sometimes you want to have the pair right away, but like I said, if I have two angles like we had here and here, then you really have the third angle up there. All right. Feel pretty good about this so far? Okay, well, I don't know if I have good news or bad news for you next. Are you ready for this? So, this might be one of the most difficult core concepts for kids to understand in all of mathematics. Okay?
Are you being sarcastic?
I'm being kind of truthful right now, but I'm gonna show it to you in a different way. Okay? This core concept is kind of goofy, kids, and kids have a hard time with it. So I'm gonna go a different direction with you to make you understand why these core concepts work. I'm gonna be quite honest with you. I'm gonna talk a little bit about this, but I really don't care if you know this or not. Okay? I really don't care if you know this or not, because I think that once you see how we're gonna handle this in the next few examples, you'll understand what we're doing. So this time, kids, instead of having two angles, the core concept says the following here: possible triangles in what kind of a case up here? Side angle case. So in other words, how many sides now?
2.
So we really only have how many angles now?
1.
One angle. So if I have one angle, does that mean I know all three right away now? No. And it turns out there's situations that happen, all right? For instance, right here, they give you a side, A and B right here, okay? And then they give you an obtuse angle A. And if they say, well, A is this long right here, if I swing an arc, will this third side touch anything down here? You know, it's not long enough to get down here, is it? So sometimes when we get into situations where, you know, two sides and an angle, how many triangles are formed? None. Or sometimes with an obtuse angle, you might have a situation where you can make what? One triangle, all right? Then we talk about acute angles over here. I don't really care what this is. By this drawing right here, is this side long enough to form a triangle? You might not get a triangle. You might get what? Two triangles, or you might get what? Oh my gosh, this is a mess, isn't it? One triangle is formed here, is this one, and this one. All right? You want to be memorizing the height is equal to A is greater or equal to B, the height is less than A is less than B. I don't want to memorize that either. In fact, you know what I'm going to tell you? I've shown you that it's possible to have what? Or, okay. Forget that this even exists now. All right? Let me show you how this works. Now, first things first. We run into these situations when we know two sides and only one angle. Okay, this is going to be a case where we're going to talk about how many solutions here.
One.
All right, so let's write down what we know so far. We're going to attack these the same way each time we start. Let's talk. Okay, what angle do you know in this problem, kids? And that is angle
B.
Okay, so no matter what we do, is B ever changing or is it staying the same all the time? B is going to stay the same. Okay. Now, here's the situation that we start looking at. What sides do we happen to know here?
B and C.
Okay. B is what length?
36.
Okay, and C is
18.
okay. Kids, when I start these are the questions I kind of start asking myself in this order. The first question I ask myself, can I find another angle right off the bat? No, because you only have how many angles? One, not two. Okay, the second question you would ask is there a pair that matches up there, the A, B, or C's? Okay, so we know angle B, don't we? And we know this B over here, all right? What I like to do sometimes here, kids, is circle the ones that are not changing. No matter what in this problem, these were given to us, right? And these are never ever going to do what? They're never going to change, okay? So let me show you what I'm talking about here. How do you know if there's one solution, no solutions, or two solutions? Remember that core concept that tells you how to figure that out? I told you to do what with that core concept? Forget about it. Here's how we're going to handle this, okay? Guys, the first thing I would be able to say is, okay, I know my pair of B's right here and we know side C, so that should allow us to solve for angle what? Okay, I got to have a quick crash course with you about stuff you've learned in the past. In your calculator, if you type in the sine of 30 degrees, what did it kick out again?
1.5.
Okay, so it's kind of like saying this. Sometimes we don't know this angle measure. It's kind of like saying, ooh, we've got the sine of some angle right here. We know that ratio is 1/2. Do you guys remember how to work backwards to figure out what the angle was? Unit circle would work, although the angles we're going to deal with are going to involve more angles than unit circle. So here's how this works. Do you guys have a second button in your calculator?
Yeah.
Okay, hit second, and then hit your sine button. Does it kick up here like an inverse function like that?
Yeah.
Sine inverse. We're going to work backwards. Inverse means work backwards. Type in 1/2 after that in parentheses. What's it kick out? So it tells you if you have a sine ratio of 1/2, then the inverse of that would be how many degrees? Okay? So what if I tell you this right here? We've got the sine of angle B right here, kids. Equals, let's just go 0.8660. If I wanted to find angle B right there, what would I have to take the sine inverse of to get back to angle B?
0.866.
Okay, so go sine inverse 0.8660 in there. And kids, I want you to just give me the nearest whole number on that.
60.
60 degrees about? Okay. So if I had the sine of some angle equal to a ratio of 0.8660, that would be an angle of about how many degrees again, friends? Okay, now, don't forget about this guy that says this. If 60 degrees was right here, wouldn't this sine value right here be the same as 60 degrees in this quadrant? What's this other angle going to be then? What's 60 from 180? 120. Think about that for a little bit, okay? If I have to check 60 degrees, I'm also going to have to check what other angle? If I have to check 80 degrees, what other angle am I have to check? Okay, just kind of bank that in your memory, and I'll show you how we're going to use that to our advantage. Okay, forget the core concept and just remember what I just said, all right? Okay, here we go on this. So, example number, what are we on, 4? Stuff in yellow changing at all? Okay, let's find angle C, okay? So I would start out as sine of what, kids?
70.
Sine of, actually I'm going to put my work over in the box up here. I can do that up here. That's what that box is for. So I'm going to set this up, friends, as sine of 70 over what?
36.
Equals, okay, now in this case I don't know C, so I'm just going to have to call it the sine of angle what, kids?
C.
Sine of C over what is length C here, kids?
18.
Now if I wanted to get sine of C alone, I would go 18 times sine of 70 divided by what? Okay, run that number, go 4 places for me. So you're going to go 18 times the sine of 70 divided 36, friends. So 0.4698. Guys, that only tells me the sine of angle C. Does that tell us angle C?
No.
So what are we going to have to do to that decimal to figure out what angle C is?
Put it into sine.
Put it into, not sine, but sine.
Sine minus 1.
Yep, so won't C equal the sine inverse of what decimal, kids?
0.4698.
Okay, I'd say nearest tenth on that angle will work.
So 28.
28 degrees?
Yep.
Okay. So C is 28 degrees. Now, here's what I want you guys to be thinking about. I'm going to draw an arrow right here, and this is important. Put a C with a little 2 down here like that. Okay? Because if I'm looking at 28 degrees, there's something else I'm going to have to look at also. And that something else is 180 minus how much? Okay, that C2 is the 180 minus 28. Which is equal to what value? 152 degrees? Okay. All right, let's talk about this. We know that C is going to be 28 degrees, right, kids? But C might also equal what other here? I'll put C2 like this, for maybe there's a second solution. C2 might also equal 152 degrees. I'll put a big question mark by this. Okay? I've already given this away. There's only how many solutions to this?
1.
All right, let's talk about this. First of all, kids, we already know B is locked in to be how many degrees? 70 and 28 would add up to how many degrees totally?
90.
So is there room to get back up to 180 yet for that last angle A?
Yeah.
Okay, now think about this. If we consider 28 degrees as a missing angle, we also need to consider what other angle, since we were given only one angle to begin with. We'll take 152 and 70 so far and add them up. I got to add 70 because 70 is not changing. What's 152 and 70 add up to? Is there room to get to 180, or have we already exceeded the limit?
We've exceeded the limit.
So is 152 even a possibility to use in this case?
No.
Absolutely not. So we say, you know what, 152 and 70 exceeds that 180 limit, therefore can't use it. Therefore what? Okay, so here's the deal, kids. We've got 2 angles, which means now we have what? 3. Okay, so we're at 98 total. How much more to get to angle A? Okay, you guys on your own then. You know that's 82 degrees, so we're going to go sine of 82 over A. equals, I'll go back and use B, sine of 70 over what, kids?
36.
Sine of 70 over,
36.
yeah. So, I'd say go nearest 10th on that again. 37.9 I'm hearing?
Yep.
Agreeance, kids? Guys, what's the order on angles from least to greatest here? CBA. How about the order on sides from least to greatest? Pretty good chance we're correct? Okay. I'm going to go ahead and pause there while you head to lunch, and we'll pick this up. Somebody remind me to start the recording. Guys, the next thing we're going to look at again on the next page then is a situation. What's example 5 say on the next page there?
I'm gonna go with no solution.
Okay. So we're going to start this all the same way. Let's write down what we know. How many angles do we know to begin with?
1.
Okay, when you only know one angle, that sets up a possibility to be a situation where there's 0 solutions, 1 solution, or 2 solutions. This example is going to have just no solution, and I'll show you why. Okay. Okay, what's side A equal, kids?
7.
And then side B is 4. And side C here. Okay. All right, kids, so in this situation right here, I don't know if there's going to be 1 solution, no solution, or 2 solutions, but again, we're going to start the same way. Is there a pair that we know right off the bat?
Yes.
40 and 4, right? So we're going to go sine of 40 is to what? 4 as, okay, what's the other information that we know up here besides the B's?
Side A.
Side A is 7, right? So we're going to call this sine of
7.
A over 7. All agree with that? Okay. So to find angle A right here, we would go 7 times what first, kids?
Sine of 40.
Sine of 40 and divide by
4.
4. So here's what I want you to do. Figure out what that decimal is, and we'll have sine of A.
I don't think this is
So give me 4 places on that. 7 times sine of 40 over 4.
I feel like this is wrong. I got 1.1249.
1249, Cora?
That's what I got, Cora.
Okay.
All right, so let's talk about this right here. So to find that angle A, what would we have to do next?
Reverse.
Okay, so sine inverse. So A will equal the sine inverse of what is that? 1.1249.
Yep.
So type that in, get an angle. Sine inverse of 1.1249.
Domain error.
Anybody else getting an error?
Yeah.
Okay, let's think about this. You guys know your unit circle, right? Okay, if the center's right here, the sine values are above and below. What's the highest point above the center here? How high up is that sine value at the very top? 1 unit. How far below? So when we're doing inverses of, I should say an inverse sine of anything, your range has got to be from -1 at the bottom to 1 at the top. What value are we trying to inverse here?
Bigger than 1.
Bigger than 1. Okay, so well, that's a problem right here, isn't it? Your angles need to range from, I'm just going to put it like this, -1 less than or equal to your angle ratio up to 1 in order to get an angle. Okay, does this fit that window?
No.
Absolutely not. This here, is this good or is this bad?
Bad.
When we get something like that, this is domain error. This means what?
No solution.
Okay. Okay, so do you understand why there's no solution there? We can't find another angle because the ratio that we came up with for sine of A was outside that range from -1 to 1. All right, so we've looked at 0 solutions, we've looked at 1 solution. We better explore what here, kiddos?
2.
All right, I like this last problem. Put a star by this last one because this is really what I need you to understand today, okay? Put a star by this last one. here it is. All right, so I'm gonna start the same way. A, B, C, little a, little b, little c. What do we know, kids? B is 55.
A is 20.
Little a is 20.
Little b is 18.
Okay, I'm just gonna circle these, kids, because these are not changing at all, are they? Okay, so the ones I've circled, not changing at all. Okay, first question I like to ask myself, do I have one angle or two angles? One. So can I find another angle right off the bat or not? No. Okay. But do I know a pair of sides now?
Yes.
Let's work with B. We're going to go sine of what, kids?
55.
Over.
18.
Okay, I think the next thing we should probably find is angle what here then, kids?
A.
Angle A. So we're going to say as sine A is to, what distance is little a?
20.
Forgot to put 20 in there. All right, so 20 in here. So go 20 times sine 55, divide 18. Tell me what sine of A is equal to.
0.9101.
Does that fit the window?
Yeah.
91.
0.
02.
Okay.
Going around up, I guess.
So the inverse of 0.9102. What's that get you for an angle?
65.5.
65.5 degrees. Okay. Now, we also better check an A prime then when we do this, which would be 180 minus 65.5. Okay, we think the angle A is how many degrees again, kids?
65.5.
Okay, I'm going to put like an A prime over here for my second triangle. What is 180 minus 65.5?
114.5.
114.5? Okay. Kids, I got a question for you. Does 65 and 55 still allow us room to get to 180?
Yeah.
So I could find C down here, right?
Yeah.
But here's another question. We already know that B, no matter what, maybe A is also what other angle, kids?
114.45.
Okay. B would stay 55 degrees, wouldn't it? Guys, what does 114.5 and 55 add up to? Ooh, so have we surpassed 180 yet or not?
No.
So is it possible to have two types of triangles here now?
Yeah.
Because we don't exceed that 180 value in either case, do we? With the first two angles? Okay. Kids, when I go that route right there, do you understand sometimes why there's 0, 1, 2 triangles now? Do you want me to try and explain the core concept about that, or do you just want to keep on keeping on with what we've got here?
Keep on.
All right. So guys, in this case right here, let's work this first case. I'm going to put a little cloud around this because this is going to be our first solution right here. All right, so once you know A and B in this situation for your first solution, could we find angle C easily now?
Yep.
What is this going to be? 110.5, so I think this makes, no, 120.5 when I add them, right? So this should be 59.5 degrees out here. Okay? So let's use this in triangle 1 to find length of C now. So give me another little bit of room to work with. Can I come over here and say, okay, sine of how many degrees? Sine of 59.5 over what? Could equal, can I go sine 55 over 18 again, kids? Okay, you guys tell me what you get for that.
18.9.
You said 18.9, Laura? Yeah. Okay, so when we do that right there, we get C equal to 18.9. Okay, so my question is this, have we solved case 1 for this triangle?
Yeah.
Okay, angle, if the angles are this, then the sides must be this. Okay, now keep in mind, what I'm going to do over here is this, I'm going to put a little a, a little b, and a little c over here on the side. And this outside columns, this will be my combination for the second solution, or second possible triangle with the information that was given up here, okay? So again, A is staying at what, kids?
1.
Because that was given to us up here, wasn't it? And B is also staying at what? Okay. But this time, we've got a second triangle. We've got A being a different angle than 65 and a half. We've got 114 and a half, okay? So find C in this other triangle, the second one.
10.5.
Okay, so if I want to find the third side of this second triangle, here we go with it. We would go sine of how many degrees?
10.5.
Is to C again as, I'm going to stick with the ones I know. Sine 55 is to 18. And friends, if you're punching numbers in there, I'd sure appreciate an answer to the nearest tenth there.
Just 4.
Four-ish?
4.0.
Okay, so C is right at 4. Okay. Things to check here, kids. How many solutions here?
2.
2.
Okay, the inside triangle order would go B, C, A, wouldn't it here? Does it go B, C, A for sides on that first one?
Yeah.
Okay, order on this here would go C to B to A, right?
Yeah.
Does that work here? C to B to A?
Yep.
Okay. How do you guys feel about this? Law of science. It's a neat unit, but it's really a pretty simple
It's simple.
idea. Okay. Are you good on finding area of triangles? The half AB times sine C.
Yes.
Okay, and the two sides have to include the angle, or the two sides have to make up the angle you're taking the sine of. How about law of sines here in terms of 0, 1, and 2 solutions? Okay. All right, so guys, no assignment. We'll kind of start looking at this tomorrow. Questions at all for me? All right, you guys.